Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In the last episode, we worked on preparing the engine to be used with the editor. We also added new functions to the engine DLL project, which forms the interface between the editor and the engine. Now that all basic functionality is exposed to the editor, we are ready to write some code on the editor's side that will call the engine functions in order to do rendering. Before we write any code, note that I already updated the Agility SDK NuGet package and also updated its version number in d3d12 core.cpp. Also, I use a different Visual Studio version in order to run the editor. This is just because of a messed up Visual Studio installation on my machine and is temporary, so I'll revert this back to version 17 before committing the code. Okay, let's start coding. We do have two small fixes here in engineapi.cpp that I'd like to do before we start. First, note that calculate thresholds also fills in the array of entity IDs. Although this is technically correct, it makes me a bit uneasy to have a function that outputs data that's unrelated to what it's claiming to do. So I'd like to provide this data as the input to this function. Instead of getting entity IDs here, I'll move this call outside of this function and make this parameter an input parameter. And of course, we don't need this parameter any longer. Now we get the entity IDs here and pass the result to calculate thresholds. And we create lights if the first light is not valid. Okay, that's all. Now we can start working on the editor. The first step is to improve and expand the code in RenderSurfaceHost. This is the class that hosts a native window for each one of the editor's viewports. We can see the viewports here when we run the application, which is now blocked because of this asinine Visual Studio pop-up. So anyway, these blue viewports are actually 4 native windows that are hosted within the editor. Therefore, we would like to update RenderSurfaceHost to support rendering, and also fix this issue. Here is an unrelated imported native function, and I think it's better to move this to a helper class. So let's add a keyboard helper in helpers.cs. Here we'll use a new way for importing functions from DLLs, which is better because it generates the marshalling code at compile time instead of at runtime. This can improve performance for functions that are called frequently or need non-trivial marshalling. To make it easier for us to work with this function, I'm going to add an enumeration for all virtual key codes in a minute, but let's finish the code for this helper class first. Another method that could be useful is one that returns the array of keys that are pressed. Although we are not going to use this one yet, I just added for the sake of completeness. Okay, so these virtual keys are the same ones we added for our Windows keyboard input handler a while back. You can watch how I added these in this video, so I'm not going to repeat that here and I'll just paste the code that I prepared beforehand. One difference with using DLL import is that these methods should be partial instead of extern. The reason is that the body of the method that contains the marshalling code will be generated at compile time, which is another partial method with the same name and signature. And this is not virtual key. Now we get this error because library import requires us to allow unsafe code in our project. I'm sure we can find it in the project settings somewhere, but it's faster to add it by hand directly in the project file. If I can manage to spell the simplest words correctly, that is. Okay, let's work on RenderSurfaceHost. Here I'll add a new class that is used as a parameter for rendering. It contains the surface ID of the viewport that's going to be rendered next, and the light set and the camera ID which are used for that viewport. We also define a callback type that returns an instance of frame info. The frame parameter is the number of frames rendered so far for the viewport. We are going to do the rendering independently from the UI thread. We do this by using a separate thread on which we call the renderFrame function of the engine DLL. It's not necessary for any other class to know about the render thread. Therefore, we'll define it as a private static class. It's static since we only need one render thread. Let's finish writing RenderSurfaceHost before implementing renderThread. As we know, each viewport will use a RenderSurfaceHost for hosting a native window, so we can add a field for renderFrame callback for the viewport. The auto-reset event makes it possible for us to wait for the host to become available for rendering. We'll see how it's used in a minute. We don't need this getKey function, because now we have the helper method for this. I'm going to import another function that's specific to RenderSurfaceHost. According to the documentation, we have to call destroyWindow in the destroyWindow core method of this class. That's why we have to import it here. There is also a Boolean property for checking if the host is ready for rendering. This should be public. When a RenderSurfaceHost is created, we pass a function pointer that will be called back every frame. This will provide the frame info. And apparently this class has to be partial in order to contain partial methods. Of course, we have to update the call site where the host is created, which is in the RenderSurface view. We'll work on that in the next video. First, we need to make sure that our graphics surfaces are removed properly. We can do this by overriding the dispose method of hWindowHost. As we can see, it implements the iDisposable interface, and therefore we can override this method. Here we can unregister from the render thread. Obviously, this method doesn't exist yet, so we can generate a placeholder for now. When disposing, we also remove the render surface by calling this engine API function. The waitReady method will wait for the auto-reset event to be signaled. And this reminds me of an unnecessary async task in import files async. This is not needed since we'll be waiting down here anyway. Going back to RenderSurfaceHost, we'll register the host with the render thread after the render surface has been created. Again, this method doesn't exist yet, and I'll generate a placeholder for it. We set host ready according to a property of the render thread that indicates if the thread has started. Finally, we signal the auto-reset event so the waitReady method can proceed. We moved the code from destroyWindowCore to the dispose method. Here we only need to call destroyWindow. We also have to override windowproc, set handled parameter to false, and return a null pointer. According to the documentation, this is needed in order to satisfy the window host contract. This is basically what we see here as well. This is all we need for RenderSurfaceHost. Now we can implement the render thread. Here we need a dictionary for pairing window handles and callback functions. In addition, we also have a list of callbacks for quick iteration in a for loop, as we'll see in a second. I suppose we could also do without the dictionary, since window handles are not needed for rendering, but let's keep it for now. We keep frame numbers in a separate list. This is of course optional for in case we would like to provide this information to the rest of the editor. We use a lock for synchronization, since callback collections will be accessed through different threads. And of course the render thread, on which we call renderFrame. IsRunning property indicates whether the render thread is currently running or not. Registering a callback will add it to the collections if no entry with this window handle exists. If this is the first callback, the render thread will be created and started. On registering a callback, we'll remove it from the collections if there is one that goes with the provided window handle. When there are no callbacks left, the render thread will be stopped and closed. Note that we call the stop method asynchronously to avoid a deadlock, which I'll try to explain shortly. Obviously, the thread field shouldn't be read-only if you want to assign a new thread. There's not much to starting and stopping the render thread. As you can see, it will call our render method, which will loop until isRunning is set to false by the stop method. Here we also use a lock, and that's why we had to call the stop method asynchronously, because it was being called from within a lock itself. And since it would wait for the thread to join, it would never exit the render method. I hope that explanation made sense. In the render method, we'll call back each viewport for providing the frame information. However, I forgot to import the new engine API functions, so we have to do that first. We exported 4 new functions from the engine DLL, if I remember correctly, and now we have to import them into the editor. Let's use the new method for importing native functions here as well. In fact, let's also use it for the Content Tools API. One thing that we can improve here is that we can pass arrays of primitive types like integers, floats, and bytes directly to imported functions, and there is no need to copy the array to an interop memory buffer. We could always do it this way, but somehow I forgot. So basically we don't need this method here. Now we can import the new functions. The 2 engine functions are trivially imported like so. For the entity functions, I think I need to write a little bit of code for update component, which should be similar to create game entity. I think that I need to rewrite this a little bit though. First of all, the geometry component here implements iDisposable, but we are not disposing it properly. To do so, I'll make GameEntityDescriptor implement iDisposable too, and then call geometry components dispose method in here. The instance of GameEntityDescriptor that we are creating here is automatically disposed of by adding the using keyword. Also, I'm going to write this a bit differently using pattern matching. And do the same for geometry. Recall that we are using a mutex in Engine DLL to synchronize data access. Therefore, we don't have to use a lock here. And since we don't use the lock, we can remove this method. Update component returns an integer, which is basically a 32-bit boolean. I don't like to use the boolean type because I don't care to remember its size in each language or implementation. It's a stupid type anyway. For C# part of this method, I'm going to copy parts of the createGameEntity method. At the end, we call the imported function. Importing getComponentID is also straightforward. Oh, wait. We can't use library import for passing class type parameters, at least as far as I know. So here we have to use DLL import again. And since we changed create resources parameter type, we have to update it wherever it's called. And the same holds for remove game entity. We can delete this lock as well. A library import can be used when passing a string, but we have to specify string marshalling. Oh, we are already doing that here. Alright, now we can return to writing our render method. Well, the only thing left is to call renderFrame API function. And that's it, pretty much. I'll do a little bit of cleanup and then we can call it for today. Next time, we are going to create a custom control that will use the RenderSurfaceHost for rendering, which will also handle user input for interacting with each viewport. As always, thank you for joining me and I'll see you next time.